Okay, in this set of lectures we will take a look at a couple of things. One is file compression, the other is remote access or remote login. Okay, so we are in Csis 248, operating system programming, and this is a bunch of miscellaneous Unix topics. The title of this chapter is Farewell to Unix, but we're not actually saying goodbye to Unix. We're just looking at the last few commands that we will need to then jump into C programming and more detailed look at the Unix system, or Linux system in this case. So this part is part 2 of chapter 14, remote access and file compression. We will look at file compression first. Okay, so I'm going to quickly zip over to the file compression part of this lecture. Here it is. Okay, working with compressed files. So you might have seen that with the tar command you can take a complete directory with all its subdirectories and files and subdirectories inside subdirectories and so on, and create one file out of all of that. Typically what's done is that file is often pretty large. Although you can use it, it's probably better to compress it and make it smaller so that when you download something like that, it doesn't take a lot of time. Also, you can compress files and then save it to disk as a compressed file too, and that saves space. So large files and software packages are often compressed to save space at things like anonymous FTP archives, where you can download these software packages. These files are usually made available in tar format with the file extension such as .tar.z. This tells us that this was first tarred and then compressed. You will see that combination a lot. You may not always see the .z compression, which is the standard Unix compress. That's the output of the compress command. Often we will use the new compression format gzip, so you'll see .tar.gz, but you'll still see this. So once you get a file like this, you must first uncompress it. So you do operations in the reverse order. When you create a compressed tar file, you tar it and then compress it, and when you unpack it, you have to uncompress the file first and then use tar to recover all of the directories and files and things inside that tar file. Okay, so let's take a look at compress. Compress is used to reduce the size of the file to save space. Running compress on a file, the original file is replaced by a file of the same name but with the extension .z. So let's take a look at this real quick. So chances are, if you have your live DVD and you type in compress, it'll say it's not found and that you have to download it. So let's do that. So remember, you have to do sudo apt-get update first. That'll work assuming that you have a network connection. So if you have a network connection, you should see output like this. Take a little bit of time to update your repositories, local information about your repositories, and then so now you can install apt-get install compress, and we got this error message. Okay, that's fine because it is actually uncompress. So sudo apt-get install uncompress. It's n followed by the word compress. And it should work. Alright, so there is uncompress. And now if you try to execute the command uncompress, it's not going to work, I think. Oh, it's not found. So the actual command is compress, as described in the book. Not everything works exactly as in the book, but I think the command name is compress. To uncompress, I think you have to use, by default it'll work from a different package, and so if you want it to work as shown in the book, you have to use something slightly different. Okay, so let's try this. So let's take a look at this file, my file. It's just got a few words that we were checking with the spell program. Let's try to compress that. Compress my file and nothing. So let's see if that worked. Nope, it didn't create anything. So let's try some other options. -v my file. Okay, so here's why. It says no compression, my file unchanged. So chances are that file is just too small. So what we can do is double the size of it. My file and my file. We'll concatenate the two. That's what cat does. Into my big file. So you do an ls-l, you should see my file is 41 bytes, my big file is 82 bytes, a lot bigger. So now let's try to compress my big file. And maybe nothing. Let's just take a look. ls. Oh, it worked. So now notice you have your my file. My big file, which used to be there and was double the size, that is 82 bytes, has been replaced by my big file.z. And it is not quite 82 bytes, it's a little bit smaller, not that much smaller. So what you're aiming for typically is for a big file to be reduced substantially in size so that you save space. But compression algorithms usually don't do so well with small files. So that's why it's much better to take a whole bunch of small files, put them into a tar file, and then compress the tar file rather than trying to compress each individual small file. Okay, so let's try to do that with our tar file. This might take a while, so let's get it started. Compress android.tar. So remember, we created a tar file using all of the information in this Android workspace. It's a huge file. It was 19 megabytes, a little bit bigger than all of the files that are in this workspace. So let's try that. Android.tar. That was fast. I'm impressed. Okay, so notice that android.tar is gone. We used to have a file called android.tar. Now it's replaced by android.tar.z. Alright, so let's take a look at the size of this. Not bad. It went down from 19 megabytes to 15 megabytes, so 25% roughly. Not too bad. Okay, so now let's take a look at our notes. Compress, as we just saw, is used to reduce the size of a file to save space. Running compress, the original file is replaced by a file of the same name but with extension .z, and we just saw that with two files, one small, one large. So we had a file called mybigfile. We ran compress on it and it created a different file. Got rid of my big file and it's smaller. Same thing with android.tar, was 19 megabytes, was replaced with this android.tar.z, which is 15 megabytes. Okay, I hope that makes sense. So if you were to list the files, if you had a file named important, compress it and you would see important dot, in our case, uppercase Z. You can use the -v option as we saw, and if it doesn't work, it sort of gives you some hints saying no file was created. We saw that with a small file. So the size of the file apparently is somewhere between 41 and 82. Somewhere between there is the cutoff. If it's too small, roughly between 41 and 82 bytes, it's not going to compress, it's not going to work. You need something, I guess, roughly maybe at least 82 or somewhere in there. Otherwise, it's not going to work. So if you have really small files, yeah, no point in compressing. Now let's take a look at how to uncompress. Now it turns out if you say which uncompress, I'm guessing this is not the one that we want to use, although it sounds like it should be right. Do a man compress. We saw that there is an uncompressed file that comes with the GNU or new zip archive. So it turns out if you do a man compress, you will see that the command is called uncompress.real. Let's check that. Let's say which uncompress.real. Okay, so the reason for this is that for the GNU tools install a file called uncompress, and so the original Unix compress is actually this one. Alright, uncompress.real, and let's try my big file.z. Let's hope this works. It looks like it did nothing, but let's check. Sure enough, it worked. There it is. So we saw our original file, if you remember, was about 82 bytes, double the size of my file. It was compressed down to 69 bytes. And if we ls-l, my big file, see it's back to 82. So of course file compression has to work like that. It has to be lossless, that is, if you compress and decompress or uncompress, you should recover everything. You should not lose any data. It's a lossless compression. Okay, so now let's try to do the same thing with our big android.tar.z file. So let's time it too. So remember the time command will time a command. Uncompress.real android.tar.z. It doesn't take that long. I thought it would take longer, but it really doesn't. Less than a second. Not too bad. That's a 15 megabyte file. Pretty impressive. So let's check this. And sure enough, there it is. It's all back. All of it is back. 19 megabyte file. Okay, so that's basic compression and uncompression. So to uncompress, you just say uncompress, and in our case, it doesn't quite work like this. We have to say uncompress.real to get to the original Unix compression to work. In the remaining time, let me just go over a couple of other things that you can do. You can use gzip. This comes in standard with the live DVDs. So let's try this, and let's time it. Time gzip android.tar. Not too bad, and it's probably a little bit longer, but I think it does a better job. Let's check. Sure enough, look at gz. Gz gives us a file that's about half the size. That's not too bad. Let's try unzipping it. To unzip, you just have to say gunzip, new unzip. And that's pretty fast too. Of course, it'll give us back all of our contents as before. One other thing that you could try is the bzip program, which is slower but even better than gzip. So let's try that. So bzip2 android.tar, and let's time it. It is slower, but supposedly it does a better job. Let's take a look. Sure, it does a little bit better job than gzip.